So when we're talking about creating our intervals, in particular, we look in terms of things called levels of confidence, where the level of confidence is essentially the probability that the interval we create will contain the parameter that we're trying to make an estimate of. For example, when we're talking about something like a mean value, we could create a range of values so that presumably, if we make it large enough, we have a 90% chance of getting the mean mu inside of it. Where to get that, we think in terms of things called critical values, where our critical values are essentially the ends of our interval with respect to some kind of standardized distribution for this setup. In this section, we'll look at it in terms of z-scores, and the next one we'll look at it in terms of things called t-scores, but essentially these are just the ends, where I'll say I don't really like that notation very much because these critical values are not quite the same thing as what you'll see in calculus where you talk about a critical value. And there are other names that people use for this anyway, where you talk about it in terms of rejection or non-rejection things, as we'll see in chapter 7, but I'm going to stick with the idea of critical value because it's what the book uses. Just understand that if you've seen calculus before, it means something a little different there, and don't worry about that connection, which is a bit frustrating, but it's what we have. Anyway, essentially these are the most unreasonable things we can consider, and if we want to get those most unreasonable values, it's good to think about this in terms of something like a distribution, even though that picture is not what we're always going to be using, where what we do is work in a couple steps. We take the complement of our level of confidence. So if we have a 90% confidence interval, then we're looking at the remaining 10%, and divide the complement in half as we're going to be splitting it into the ends. That is, our 90%, if we're talking about that level of confidence, is going to be the values in the middle. So we'll have the 10% split into 2 5s on the outsides, and then use the distribution that the data is described by to find the value separating those tails, the left and right side, from the middle, which is always going to involve some form of inverse function, where we have that picture, as I said, to get an idea of this. So, for a different example, not just 90%, if we have something like 91%, then we'd have 9 on the outside, and that means 4.5 in each tail. So if we want to find the critical values associated to that, we would be looking for the values in our distribution, whatever distribution it may be, that give us 4.5 in the left tail and 4.5 in the right tail. If you want to think about that in terms of just areas to the left, we'd have 4.5 to the left of the smaller one and 95.5 to the left of the bigger one. Where from here, we're going to talk about how we can actually get the entire interval from those values, where we can make our window that we work from, which is a value in this context called the margin of error.